Well, thanks for coming. So I'm Ravi Kapoor from a company called Imperative Space. And for those of you who don't know, the CCI, the Climate Change Initiative, is a long-running program that brings together a very large community of climate scientists who are all working in thematic focus areas around essential climate variables. And it is now moving into its next phase of activity, and there's a lot of cross-cutting activities of which the knowledge exchange is one part. And I'm accompanied today by Thais Rosan, who's going to give us an overview of the particular area she's working in relation to estimating CO₂ emissions. Before we get into that, I just want to quickly give a bit of context about the other activities going on in the CCI Knowledge Exchange. So I mentioned that we are the lead of the training activity, but that's just one part of a lot of different components, including a very ambitious communications activity that's intended to really engage a wider public and policymakers and other key audiences in the impact and activities of the Climate Change Initiative. There are various interactive apps and tools to enable easier navigation and browsing of data and understand its implications, including something called the Climate from Space app, which is a globe-based data browser tool. There is an open data portal, which is a large and very fast-growing access point into all of the key CCI datasets. And associated with that is a Python toolbox to help developers and scientists in adjacent areas work with the data more effectively. And then finally, there's a communications lab, which is experimenting with novel ways of working with the data for visualization purposes and public engagement purposes. So within the training activity, this seminar is the first of what will be a long series of seminars over the next 3 years that will focus on different thematic areas of the climate system and different ECVs. The seminars will mainly be held at events like this, but also larger events such as the Living Planet Symposium in June in Vienna, and potentially also at the COP30 event later in the year. We're also running a series of online training events which make use of Jupyter notebooks and a core training environment which has been developed especially for the program. And all of this is going to be archived on a special site on the ESA climate site, which is climate.esa.int, over the coming months. And we're also going to be running a series of large-scale competitions. These are going to be challenges, sometimes taking the form of hackathons or opportunities to do some coding, but also they will engage with wider audiences too, and will be about galvanizing and engaging more understanding of climate data per se, and supporting new audiences in interacting with the data. So, just very quickly, there are some key links. I mentioned the Climate Office website there in the middle, but if you have any questions about what you hear today, please do reach out to us. You can get in touch with that email address there, support@imperative.space. And you can also follow what's happening within the overall activity on social media. All right, so I'm now going to pass over to Thais, who will just take us through the next 30 minutes, her area of research. Over to you.
Okay. Well, I don't work for ESA, but I have been using their products in the last 3 years on my research and also in the research of my lab. My name is Thais Rosan. I'm a postdoc at the University of Exeter, and I will present these insights from our carbon cycle group. So, just want to give an overview why it's important to have accurate CO₂ emissions. So to effectively mitigate climate change and achieve the Paris Agreement goals, we need precise and up-to-date estimates of carbon fluxes. Here in this figure, I'm showing the global carbon cycle on the global carbon budget. So in Exeter, our group have been working mostly with the land component, so mostly with land use change and the carbon sinks. But we also have the group that leads the global carbon budget there and get all this information from several groups worldwide and put everything together. But we still have large uncertainties on these components, and one of the large uncertainties is on the land component. And we have been trying to use more Earth observation data to improve and to reduce these uncertainties. Now I will show a little video about the recap project that was made for ESA before. I also worked into this project when I came to Exeter. And although we have more updated data from this presentation, I will show this so we can understand a little bit how we use satellite data into these models.
Over the last century, the burning of fossil fuels has increased the concentration of atmospheric carbon dioxide. Greenhouse gases accumulate in our atmosphere, causing Earth's temperature to rise. In 2015, the Paris Agreement adopted a target for global warming not to exceed 1.5 degrees Celsius. This sets a limit on the additional carbon we can add to the atmosphere, known as the carbon budget. Today, only around 17% of the carbon budget is left. This is 10 years at our current rate of emissions. Across the globe, each country reports its annual greenhouse gas emissions to the United Nations. Scientists set these emissions against estimates of the carbon absorbed by Earth's carbon sinks. This is otherwise known as the bottom-up approach in calculating the carbon budget. Another way to track carbon sources and sinks is to measure the amounts of greenhouse gases in the atmosphere from space, the top-down approach. As well as tracking atmospheric carbon, ESA's Climate Change Initiative is using satellite observations to track other carbon stocks on both land and sea. How we use land accounts for around a quarter of our greenhouse gas emissions. Forests and their soils are the largest store of carbon on the land. Fire acts as a conduit for carbon to pass from the land to the atmosphere. And phytoplankton in the ocean are an important carbon sink. ESA's Regional Carbon Cycle Analysis and Processes project is using this information to reconcile the differences between the bottom-up and top-down approaches. Observations are combined with atmospheric and biophysical computer models to deduce carbon fluxes at the surface. This will greatly improve the precision of each greenhouse gas budget and help separate natural fluxes from agricultural and fossil fuel emissions. This will help us gauge whether we can stay within the 1.5 degrees Celsius carbon budget, or if we have to deal with the more severe consequences of further warming.
Okay, so in this video we saw that all the potential of the Earth observation data for using on climate change science and also application. And here I'm just showing that the satellites, they offer a continuous and large scale observation of the Earth and give lots of different components that we can track. So from ESA CCI, we have the ECVs that is shown here, and we can access them on this dashboard. Also here is just showing the types of ECVs that are available. I work mostly with the biosphere, the above ground biomass, the land cover, and fire data, but we have a lot of, a big range of data that can be used for water studies, cryosphere, atmosphere studies, biosphere as well, hydrology, and other applications. Now I will give my presentation about the studies we have been developing at the University of Exeter. So I will start with this study. That was the first study I did when I came to Exeter to work at the carbon cycle group, and also within the RECAP project. In this study, we were looking at the uncertainties of the land use change emissions for Brazil within the global carbon budget models. In the global carbon budget, they use a different approach to estimate the land use change. They use a product that is based on statistical data, and then this product spatializes the statistical data for each country to a grid, and then spatialize the land use changes for all the countries in the world based on some assumptions. This product is called HIDE. And in this paper, I made an assessment of different land use products and how they impact the carbon emissions in Brazil. And I didn't put the figure here, but the product that they were using in the carbon budget before, it was showing a lot of emissions here in the southeast of Brazil, which is not what is happening. We know that most of the deforestation is within the Amazon in Brazil. So I was looking at all these products to try to find how we could correct this and why this was happening. This was happening because of the products that it was being used on this database. And with this work, I showed that we could use another product and more Earth observation data from ESA CCI and also some local data from biomas in Brazil to improve the spatial allocation of these emissions for Brazil. So using the ESA CCI land cover data in this global land use data sets used in the global carbon budget, we improved the spatial allocation of the land use changes in Brazil and also the emissions trends. Here I'm just showing, like, in general, the emissions from the land use sector. This first figure is from the global carbon budget 21. So here it shows like the gross sources and sinks, that's deforestation and, for example, the regrowth of secondary forest, and the net source. And then there is some difference compared to the GCB 24 because we improved these data sets for the land use data used to run these models. And now, because we have a little bit more detailed information about countries, we can also give the emissions within the global carbon budget by each country, and we can see that Brazil, Indonesia, and DRC is one of the greatest emitters of land use change. All the information about the global carbon budget you can find on the global carbon budget website, and there is also the global carbon atlas, so you can get the information for each country. And I think it's not just the global, it's not just the carbon budget, but they have like the methane budget as well in the carbon atlas. Now I will show a little bit the other studies. We are working on the land use side, but we are also working on the carbon sink side. So this is led by Viola Heinrich, that was part of some of research in Exeter. She uses the ESA above ground biomass data and other data from secondary forest age, and she could model the regrowth rates of secondary forests across the Brazilian Amazonia, looking at also some disturbances and how these disturbances affect the carbon sink of these forests. And she found that there was a net change in 2017 of 11.9 teragrams of carbon. And also with this data, we can spatialize and see where we are having losses and gains of secondary forests. And this is really important for climate mitigation in Brazil because we have a large potential for secondary forest regrowth and natural-based solutions. Here is just another graphic showing, because there is high turnover in the secondary forest, they are deforested again, within 5-8 years. So she did some simulations looking at if we preserved everything we had in that year. I think the baseline year was 2017, how we could accumulate in carbon in the future. She put 2030 because we have the commitments. And then if we preserve just age, so just secondary forest older than 5 years, 10 years, 15 years, 20 years. And we can see that we reduce a lot if we keep cutting and deforesting these secondary forests, because the youngest one, they accumulate carbon faster in the first 20 years. But we need to protect the secondary forest so we can achieve these goals, but also we need to still protect the primary forest or old growth forest. Because some people might say, if they regrow faster and they accumulate carbon faster than the older forest, it's better to cut the older and plant new. But no, there is other process as well, like biodiversity, and that we're gonna lose. And we're gonna lose also large amounts of carbon that is stored in these old growth forests. So we need law that protect both the secondary and the primary or old growth forest. Then Viola, she expanded this study across the tropics. So she studied the Amazon, Borneo, and Central Africa. And she did kind of the same modeling using the ESA biomass data and another global data for secondary forest age. And she found that in Borneo, the recovery, the regrowth rates in Borneo were much higher than Central Africa and the Amazon. And this is really important to understand the variation in forest regrowth, because we can guide, tailored reforestation and conservation strategies for this forest. Here is just showing a map showing the variation of the stocks for the whole Amazonia. It's not the Brazilian Amazonia here, but also the whole Amazonia basin, and also the other countries as well. And in this paper, she studied secondary and degraded forest. So she also looked at how degraded forest was accumulated carbon over time. And if we consider both degraded and secondary forest, we could counterbalance about 26% of the emissions from forest loss in these countries. So it's quite a lot, but we keep also deforesting this secondary forest as well. So here in our group, we also are working in a project with ESA to develop a regional fire model for Brazil, for the Amazon and the Cerrado as well. That is the Brazilian savannas. This model is called BFIT. We are currently testing and working on the paper This work is led by John Fawcett. And this model, basically, they use the ESA CCI biomass data and data of burned area. We did some tests with the MCD 64, but we are going to expand to use the CCI fire and potentially finer scale spatial resolution as well, and not just moderate spatial resolution. And this model is different from what we have, for example, GFAT globally, because we use some data that is from local run-based studies. For example, we have the regional wood biomass density data from the field, and we also have biomic specific estimates of post-fire mortality. And most of the fluxes from fires, they come from post-fire mortality. They will be released in the following years of the fire because of the death of the trees. So this is just a schematic showing that we apply some machine learning algorithms to try to account for the post-fire biomass, and then there is all this regrowth and decomposition and combustion as well. This is preliminary results, so this is the emissions and also regrowth related to fires in the Brazilian Amazonia. So we see that most of the instantaneous while most of the instantaneous degradations are small comparatively with the other instantaneous, the legacy fluxes, they account for 30% of gross emissions on the average. So the legacy fluxes, that is the fluxes from post-fire mortality, they are quite big. And in most of the global models, they are not implemented. There is another project that we are using as well, some ESA data. So we are using these GGVMs, that is called the dynamic vegetation models, to estimate anomalies in the carbon fluxes. We are trying to do like a near real-time application. So these GGVMs, they measure, they simulate lots of fluxes and variables that are not directly measured by satellites. So that's why they are useful, but they still have lots of uncertainties on the plant functional type, simulations, on the carbon fluxes and fires. So our group is trying to use some prescribed fire data, for example, from ESA, and also prescribe the PFTs for these models, so we can improve the representation of the PFTs, for example, and also the fire emissions. This is just an example that we did with this OCEAN model. So this near real time, we want to do like some GGM simulation targeted to the extreme events. So for example, we know that there was happening, a heat wave in Europe. So how it's gonna be the impact on the carbon fluxes? When we do the global carbon budget, for example, we always run the data for example, this year, global carbon budget will be up to 2023. So we have like a 1 year of gap in the data. So we want to do the near real time, so we can, have low latency, information about the carbon fluxes. So maybe we are aiming to run simulations for specific areas. So it's less cost for the group, and we can maybe when there is some fires in Canada or heat waves, we can run the models with data from yesterday, climate data, and we can see the impact on the carbon fluxes. Well, now I speak about the work I have been doing in the group. So I have been working with the carbon sequestration in the Brazilian Atlantic forest. So most of people know Amazonia, and everyone's talking about Amazonia, but we also have another rainforest in Brazil that is along the coast of Brazil. It's called Atlantic forest, and most of it is already like gone. We have about 20% of this forest intact. And these areas are restoration hotspots, so there is lots of area available for restoration, and there is lots of projects going on in this Atlantic forest area for restoration. So we want to study how these regrowth curves occurs in this Atlantic forest. So this is just an overview of what I use it as a data. So for secondary forest age, we estimate the age based on the land cover change from regional product called map biomass. We use the ESA CCI above ground biomass to estimate, to overlay the biomass with the age data. And then we use like a space for time substitution to estimate to get the above ground carbon for each age of secondary forest in the same year. I also test some environmental variables that was influencing these regrowth curves, and we use it to build the regrowth curves that I showed before from Viola's work for the Amazonia and also for the tropics. We use this model that's called Chapman-Richards. This model is really used in the forest and ecological modeling, so it's well known in the community. So we feed this model using the forest age and the associated biomass from the ESA CCI data. So here is just showing these regrowth curves for each of these regions in the Atlantic forest. So because of the sample data, we could not separate even more the regions in the Atlantic forest, so we chose to work with 3 regions. And we see that in the green area, we have the highest regrowth rates. This area has the great fraction of old growth forests, so most of the secondary forests are close to old growth fragments. So there is seed pools, for example, and it's easier for the forest to recover. And also there is higher frequency of connected fragments compared to the other regions. We run a multilinear analysis to see what variable was influencing on the carbon stocks of the secondary forest. And the forest connectivity was the main significant driver. And the MCD, WD, that was a drop index, was important in just 2 regions. And then I calculate the carbon sequestration potential. So the carbon sink from secondary forests in 2020 was about 30.3 teragrams of carbon. And the gross emissions from old growth forest loss was 10.3. So for the Atlantic forest, we have a positive outcome, a positive sink, but there is still lots of deforestation in the old growth forest. So we should aim to have no deforestation in the primary forest, and then there is this secondary forest carbon accumulation. This could contribute a lot to the Brazilian targets, to the Paris Agreement. So this is a summary of the presentation. So with this science-based evidence, we can support progress towards the UN CCC Paris Agreement goals. With the Earth observation data, there is this large potential to do the carbon budget analysis and improve this carbon budget analysis at the regional and global levels. The ESA CCI provides these essential climate variables, called ECVs, and they support this climate modeling, support like research like our group is doing, and services. And also we are very excited with the upcoming ESA biomass mission. So this will deliver critical insights into forest condition, and they change over time. So that's it from my side. Thank you. And if you have any questions.
So thank you very much, Thais. Just to mention, all of you got microphones on the table. Does anybody have any questions for Thais at all?
My name is Catherine. I'm a researcher from University of Exeter. And thank you for the wonderful presentation. I don't have a question, actually, this is a basic pointing. So you mentioned about the carbon storage potential and sequestration potential of forest. So what are your thoughts on carbon storage and sequestration potential of soil?
Yeah, we try to do some analysis based on some soil data we have for Brazil. There is this soil carbon data for Brazil, but was not like good. I couldn't get any good relationship. If with the increased age of forest, there was increase in the soil carbon, for example, I couldn't find. But I think it's because we have this limitation on the data side. So from remote sensing, we still have this limitation to analyze, the soil. But it's really important as well, and it's most important even in biomes like savannas, for example, that most of the biomass is below ground. And still there is lots of uncertainty about that, and we have lots of deforestation, even higher in the Brazilian savannas than in the Brazilian Amazon. So, yeah.
Thank you.
Hi. I'm Pauline from the Philippine Space Agency. You mentioned that you have lots of uncertainties in your measurements. Did I get that right? So a question I would like ask how do you validate your measurements? I'm assuming these are from satellite data.
Which measurement? The age, the forest age?
You mentioned you have measurements of the carbon sink. So how do you validate this?
Yeah, we have an uncertainty related to the biomass data, but that is related to the uncertainty of the biomass data map. But we know that the uncertainty is even more. But we don't have field data, for example, we compared some of our data with field work. In the paper, they have this analysis, and it's pretty similar, but it's not a validation of the data. We could get the regrowth curves from the field data, but it's just some limited plots in the Amazon, for example. And with this remote sense, we can upscale to the whole basin, but we don't have this is the exact uncertainty of the data.
All right, thank you very much. And anybody else got anything? Well, if you don't mind, I might ask a couple of things, if that's all right. I'm also curious to just know, amongst this group here, how many of you were already familiar with the CCI initiative itself? Just a couple of you. And what's the split here between scientists versus people in a policy or applications environment? Who's in a science context?
I'm both.
Okay.
Yeah.
I'm the leader, so.
And maybe if I can just ask you, Thais, in terms of the role the CCI initiative plays in the global stocktake and in enforcing the aims of the Paris Agreement, I mean, where do you feel we're up to at the moment, and how crucial is this particular activity to our collective understanding?
Yeah, I think it's really good, this initiative, because, for example, for Brazil, I know a lot of Brazil because I'm Brazilian. For Brazil, we have loads of data, loads of data from the National Institute for Space Research, for example. So we do this, I was involved in some comparisons of the ESA CCI products with the Brazilian products. When we found some things, and we are report to the group and we are improve the data. But I think what is important is because this data is global and can be used for countries that doesn't have like the resources like Brazil have to produce like deforestation data, for example. And the ESA CCI can provide that, the land cover maps, the biomass maps. In Brazil, we have some local biomass map as well, because we do like some drone and also some other analysis. But other countries like DRC or other, countries that are important on the tropics for the forests, they doesn't have the same resource. So this CCI program can help these countries to track what is happening and to achieve, the Paris Agreement targets.
So you get a global picture, you get a growing evidence base, you get a way of reanalyzing the data with latest technology, latest algorithms as they become available. But then also, is there a connect with policymakers, do you think, or do you think we need to do more to put this in front of the right decision makers and policymakers?
Yeah, I think we need to be more, in front and with these countries to try to, leverage this product to be used. In Brazil, it's a little bit difficult because we already have like a program to track, for example, deforestation. Our program is since the 1980s, so we have like a consolidated program. But in other countries, no. But I think we need to communicate better with the government.
Maybe I could put this to, yes, go ahead. I think it's on there.
I'm sorry for that.
Maybe you could just say who you are. Maybe you could just say who you are or where you're from.
I'm from the Philippines Space Agency also. I mostly do processing on the mapping part. I'm not familiar with how to calculate the gigatons of carbon and such. My question actually, since these variables are available from ESA's CCI, for example, for the Philippines, can we also calculate how many gigatons of carbon does our forest have or something like that?
Yeah, if you have like the biomass data from ESA, and you have the land cover data, so you can overlay the data and see where there is deforestation, for example, and estimate how much of biomass was lost. But you also need like a model, because some of the biomass is lost, at the cutting of the forest, and some biomass will be lost, like we call legacy fluxes. So you need like a bookkeeping model, for example.
So we cannot directly apply the Brazilian model, for example, into a model of the type of forest in the Philippines. So
Yes.
somebody should do the research and estimate the biomass for the type of forest that we have, and then we can calculate this
Yes.
in land cover
Yes.
change. All right, thank you.
I mean, there are, of course, other programs and other initiatives and other research activities going on around the world. I mean, this is an important European-led methodology to look at comprehensively across all the ECPs. But I think with an open science culture that's emerged now in Earth observation, there's a lot more interconnection, a lot more visibility between different activities. I'm interested to know, amongst you who are from a policy background, just to that point about connections, what do you think is needed? Do you find a lot of these kinds of activities stay hidden? Is it hard for you to find these kinds of
in our case, we have the coffee initiatives and
our of course, the research on calculation of above ground biomass, I don't know, but usually in my knowledge, we usually do that for mangrove forests, for example, and some crops. So, but I'm not familiar if they actually did the estimation for our forest reserves. Our research in the last few years actually is more on monitoring the progress in our reforestation efforts that's been decades in the making. We started reforesting the country in the late 90s, I think, when you were born. Just kidding. We started reforesting it, and it's been 20 or 30 years now, and we really hope that you can see the effect right now, but based on global and government and such, we're seeing a downtrend actually. So what happened with all this money and everything? So that's why, quite interested in how you apply those. Maybe I can look around because we have a different ministry or department, as we call it in the Philippines, that works on the forestry. So we're working with them right now. Actually, as part of the COP initiative, they're developing a pilot model in the Philippines to the type of forest, closed forest, open country forest, and mangrove forest. So that's their pilot study right now. And hopefully by the end of this year, when we finish the pilot study, we can implement it to the entire country.
Sometimes you cannot see a trend, as you mentioned, in the land cover change, for example, or forest change from some global maps because of the size of the pixel, and your area, Philippines, is not like amazing, like Brazil. So there is the ESA CCI high resolution land cover group. They are developing some products for specific areas. I think they will develop one for the Southeast Asia, but I'm not sure. At least for Brazil, they are developing one, and for Africa, one part of Africa. But they have all like open calls for people to say, I want this type of product, I need this type of product, and we can, talk to them and see if they could produce something, But you need to be aware of these calls.
Anybody got anything else to add? I'm curious to know if you had a direct line to the European Space Agency, which you do by us being here. What would be your number one or two top asks in terms of access to the data, in terms of visibility and publicity for these kinds of initiatives? Is there anything that you would really, really want to say is missing, or that would make a big difference in your particular area of work?
Data sets in the initially for the whole country, all the historical data sets, and eventually to the whole of Southeast Asia. So, it's right now it's a waiting game, and hopefully, I think this will be part of it eventually.
Okay, all right, thank you. Yes, you've got a microphone there if you want to grab that. Yeah, thanks. And maybe just say who you are if you could.
Hi, Grant Day. I'm from the Commercialisation Directorate with ESA. I think one of the things I've really appreciated in recent years is the ease of access through the Copernicus Open Space Data ecosystem, particularly the low barrier to entry with the Copernicus browser and some of the training things on that. I think for me one of the biggest challenges is actually awareness that a lot of this data exists and how to use it. And I think that early barrier, that easy access through that process, I think has been invaluable.
Excellent, very good. Okay. Well, thank you. I've got one last one for you, Thais, if I could. It's a slightly cheeky one, but just looking ahead to COP30, which is going to be in Brazil. Curious to know, as somebody from Brazil and somebody who's a scientist working in this field, you know, what are your feelings, both personally and professionally, about what that event is going to represent and the opportunity it carries for bringing the world's attention to this absolutely fundamental ecosystem, but also the general momentum or loss of momentum in the world right now on these issues?
I think it's gonna be challenging for like the people in Belém, in the area, but I think it's gonna be good internationally, like to showcase, you know, the Amazon for the whole world, because it's so important, you know, conference, and the Amazon plays like a pivotal, you know, role on the world's climate. So with the government we have now, they are trying to, you know, come back again to the like deforestation policy. We had such hard years before, and we gonna be like several years to recover from it. So people say, yeah, I'm gonna resolve this now with this new government here. But if we don't continue, you know, the programs, the funding, you know, to conserve the Amazon, for example, and also taking the people that live there accountable, like the indigenous people and the local people in the Amazon, because we only thinking about like preserving the forest and everything, but we also need infrastructure, for example, for these people that live there. So I think it's gonna be important for this, you know, to showcase the people that is living there, and of course there is gonna be problems with the infrastructure. We saw like this news about this new road that they are opening in Belém that is crossing a conservation area. But this conservation area allows to have some infrastructure built, and this was planned before the COP. So we need to be careful how we handle it. But I think it's gonna be really important to put the Amazon like in the center of the world with the COP. And yeah.
Well, thank you, and let's hope it does actually draw everyone's attention and eyes back to this critical issue, which has got to need a lot more leadership to get where we need to get. So, thanks very much. Thank you everybody for coming along. If nobody else has anything else to add, I think we'll leave it there. But thank you to Thais for your amazing presentation. Thanks.